Hello class, in this video I'd like to review our content about infinite series. So an example that I would like to cover for that would be to find this first 5 partial sums for this sequence and then find the sum if it does indeed converge. 1/4, 1/16, 1/64, 1/256th, and so on from that. But to first do those 5 partial sums, first partial sum as sub 1 will just be the value of 1 since that's the first value of the sequence. The second partial sum would take 1 plus a fourth. So that makes 5/4, or as a decimal, 1.25. If we do the third partial sum, this is 1 plus a fourth plus 1/16. And that one's going to make 21/16, or as a decimal, that is 1.3125. The fourth partial sum is 1 plus a fourth plus a 16th plus 1/64. And that one is 85/64 as a fraction, or as a decimal, 1.328125. And the last one, the fifth partial sum, this is 1 plus a fourth plus a 16th plus a 64th plus a 256th. So as a fraction, this is 341 over 256. And as a decimal, that is about 1.33203,125. So to find the sum if it does indeed converge, well, number one, the value for A for this is that first value, which is 1. The value for R. So as we kept going to the right here in our sequence, we could see for each one of these, we divide by 4 each time, right? 1 divided by 4 is a fourth divided by 4 is 1/16th, 1/16th divided by 4 is 1/64th, and so on. So R for this, that divided by 4, is going to be represented by 1/4. And 1/4 is within our bounds of -1 to 1. What does that mean? That just means that this does indeed converge. And you might be able to see that from the way our partial sums are going. But to actually find the sum for this would take the value of A, so 1, divided by 1 minus the value for R, which is 1/4. So this makes 1 over 3/4, which makes 4/3, or 1.333 repeating, which makes sense based upon our fifth partial sum already starting to, get closer and closer to that approximation. So let me know if you have any questions or concerns. Thank you.